Good day everyone. We are the last group and we will discuss about railway engineering. It is covered with history, subfields, components or elements of railroad, and railroad stations. First, I'm Nicole Tomas and I will discuss the history of railway engineering. So ano nga ba ang railway engineering? Ang railway engineering is an interdisciplinary engineering field dedicated to building better, faster, more efficient rail systems. The railroad industry uses these special engineers to care for and plan railway system that can transport goods and people. So sabi, sila yung nag-aaral o namamahala sa railway transport na kung saan para mas mapadali ang pag-transport ng mga goods and ng mga tao sa iba't ibang lugar. So ano nga ba yung railway? Railway is a track made of steel rails along which trains run. So let's tackle the history. So let's tackle about the history. First, it is invented in Great Britain noong 18th century. Rail transport expanded considerably during the second half of the 19th century and the beginning of the 20th century, but there was a considerable decline in the second half of the 20th century due to the increase in car and lorry use. In the last 20 years, high-speed trains, saturated roads, and the development of urban rail transport have led to a new expansion of railways. And because of that, maraming branch lines na nagsara. So first, this engine in the picture was designed by Mark Seguin. It is one to help to pull coal trains from the mines to waterways. Next, before 1800s, the road network was fairly complete, but travel was slow and uncomfortable. Wagons drawn by horses were still, with water transport, the only means of travel. Dennis Papin had discovered steam power in 1679, but there was a 100-year wait before the British combined steam traction and cast iron rails. It was also a British engineer, James Watt, who designed the first really useful steam engine in 1776. 100 years din yung tinagal para mabuo yung steam traction and cast iron rails. Next, before 1800s to 1850 in England, in 1804, Richard Trevithick built and operated the first locomotive. In 1806, with the help of William Hessop, they went on to develop the shape of wheel, which marked the true start of railways. Between 1812 and 1823, locomotives were built successively by John Blenkinson, Matthew Murray, William Hedley, Christopher Blackett, and George Stephenson. As early as 1817, Stephenson built a locomotive that pulled a 30-ton train at 10 kilometers per hour. In 1823, George and Robert Stephenson founded the locomotive factory in Newcastle, where the first engines to be used in France were built. In 1825, a passenger train began to run between Stockton and Darlington at a speed of 35 kilometers per hour. So, nung taon na yan, inintroduce ng British yung kauna-unahang fixed signaling on railways and yung kauna-unahang paggamit ng ticket. Itong fixed sa gilid is yung rocket ni Stephenson noong 1829. So before 1800s to 1850 in France, French engineer Marc Seguin, who invented the tubular bowler, persuaded the minister in 1826 to build the first modern railway line to join Lyon and Saint-Étienne over a distance of 56 kilometers. Marc Seguin took charge of the works, commissioning and the different stages of operation. He used two locomotives purchased from Stephenson's factory. Seguin found the English locomotives too heavy and too slow, and in 1829 modified his tubular bowler to produce 1,800 kilograms of steam power hour instead of 300, thereby increasing the train speed from 10 to 40 kilometers per hour. Engineer Alexis Legrand sketched out the map which provided the main structure of the French railway network. Lines were built in all parts of France. James de Richchild and Émile Perrier financed the construction of the line between Paris and Saint-Germain, which was opened on 24 August. And because of that, ginamit ni Stephenson yung tubular bowler ni Sagan sa kanyang locomotives dahil it was useful traction device. This picture is Sagan's locomotive. So next, 1850 to 1870. It is the golden age of rail. Works started on a large number of lines and the six large companies that were to manage the national network on the basis of geographical zones were set up in 1859. At the same time, in urban areas, the development of public transport resulted in the appearance of the tram, which is a railway that runs at street level on flat or groove rails. Paris was the first city to have a tram on Quai d'Orsay in 1854. Horses-drawn vehicles were still used until 1880. So, noong mga taon na yan, mas dumami yung mga railway lines na kung saan naging dahilan na yung mga farmers ay mag-worry about sa kanilang farm and hen houses. So, yung ibang lugar is mas gusto na lang nilang walang railway lines para maiwasan yung masisira sa kanilang farm. So this picture is the Crofton locomotive. This was an American Crofton na kung saan nahigitan niya yung world speed record na 144 kilometers per hour. So next, 1870 to 1914. It is the rail triumphs over the road. Ernest Goyne, an important champion of progress, was convinced that machines should liberate mankind from the slavery of nature. The guiding principle of the plan was a station for each commune. This led to the extension of local lines which were linked to the national network. Jules Ferry encouraged the signing of agreements between the state and the companies, as a result of which the network grew from 26,900 kilometers to 39,400 kilometers in 1913. In 1880, the Roebuck steam tram made the journey between Roebuck and Lisle in less than an hour. Electric traction replaced steam from 1900s, and this mode of transport remained highly valued until 1930s. In 1900s, after a 40-year gestation period and 12 years of debate in the Paris Council, Fulgence Bienvenu built the first line of the Paris Metro between Maillot and Vincennes. Because of that, inumpisahan niya yung construction sa mga locomotives na need para masimulan yung plano sa pagdevelop ng mga railway. Tapos, yung picture na to is kay Arbed locomotives noong 1900s. So next, noong 1914 to 1945, in 1918, after the First World War, railway lines and equipment were in poor condition. However, France's rail infrastructure was rebuilt rapidly and new techniques were developed. In cities, the tram developed considerably and networks were built in many conurbations. In Paris, the metro continued to grow. By the time its founder Fulgence Benevue died in 1936, the metro network consisted of 167.7 km of lines and 316 stations, with construction of another 17.5 kilometers and 32 new stations underway. The economic crisis of 1930 struck during this period of optimism. The railway companies were no longer able to meet their obligations, and the government decided to nationalize them. The French National Railway Company was created in 1938. The trams disappeared from every city apart from Marseille, Roebuck, and Saint-Étienne. During the Second World War, railways played a vital role, both in terms of transport and resistance activities on the part of the workforce. The latter resulted in large-scale destruction, which means that reconstruction was once more required. This provided the starting point of the period of modernization, which is still continuing today. So, nung taon na yan, yung mga network and equipment ay naging modern na. Yung train safety is nag-improve, nakilala na rin yung electric traction. And because of this, naging doble yung bilang ng mga pasahero. So next, noong 1945 to 1981, Modernization continued after reconstruction with the electrification of all high traffic lines, the abandonment of steam after arduous discussions, and the construction of automatic marshalling yards. In 1950, the SNCF, which had hitherto used a 1,500-volt DC supply, conducted its first traction trials with trains directly connected to the 25,000-volt AC industrial supply. As a result of this decision, a new speed record of 243 km per hour was set up in 1954 on the Paris-Lyon line on the journey between the Dijon and Bayonne. On 29 of March 1954, on the Bordeaux-Dax line between Lamothe and Morgsens, BB 9004 locomotive set up a new speed record of 331 km per hour. This record was a spectacular achievement for the time and remained unbroken until the advent of the TGV. Between 1970 and 1985, the Paris Regional Express Network was created, extending several suburban rapid transit metro lines, and metros began also to build in Lyon and Marseille first, then Lille and Toulouse. So, itong picture na to na nasa gilid, ito na yung ginagamit na train noong 1945 to 1981. So, sabi, nung taon na yan, naging tuloy-tuloy na yung modernization after nung reconstruction ng mga electrification of high traffic lines. So next, the TGV. Ito na kasi sinasabi ng TGV kanina sa my previous slide. So, it is the high-speed trains. To organize the construction of the new network, it was necessary to set up works bases with tracks connected to both the existing SNCF network and the new line. The principal differences with conventional track involve the superstructure. The lengths of rails are delivered in 396-meter sections, laid on reinforced concrete twin block sleepers and fixed with knob fasteners. The minimum thickness of ballast under these elements is 35 centimeters. The points and crossings are unusual in that they are laid on concrete sleepers and contain a frog with a movable point. In 1981 saw the opening of the high-speed line between Lyon and Paris. The trains travel at 270 km per hour. The TGV had arrived. In 1990, a new world record was set up on the recently constructed line between Paris and Tours. It is 513.3 km per hour. So, yung construction ng high-speed rail network is nagsimula noong 1970s. So, this picture was the TGV noong 1993. So, next, the last century of the history of railway engineering. It is the 21st century. The creation of the cross-channel link with the opening of the Channel Tunnel on 23 of June 1991 confirmed the technical excellence of French companies which are able to adapt to all environments with complete success. New techniques are also being applied to urban networks, both on rapid links and tram networks. The latter are making a comeback in city centers with the dual aim of integrating harmoniously within the environment and improving passenger comfort and access. Between now and 2010, more than 1,000 kilometers of electrified lines will be added to the existing network. This electrification is scheduled for 2000 to 2006 and will involve the opening of new lines including the Eastern Europe TGV and the revitalization of freight routes, which will mean more lorries will be carried on trains. So, nung century na to, mga makabagong railways na yung ginagamit and mga mas maayos and pinagandang railways.
Good day everyone, I am Jonathan Odanga and the topic that I will be reporting is the subfields of railway engineering. These are the specialized fields that compose railway engineering. First is mechanical engineering. It is an engineering branch that combines engineering basics and materials principles with material science to design, analyze, manufacture, and maintain mechanical systems. It is the branch of engineering that involves the design, production, and operation of machinery. One of the field na pwedeng kalagyan ng isang mechanical engineer is in railway engineering. They are assigned in the manufacturing and maintenance of factory, goods, and passengers. Carries before the role of mechanical engineer. The role of a mechanical engineer in railways is mechanical engineers in railways look for train operations like crew management, motive power ability, traffic restoration, repair, and rolling stock management and manufacturing, etc. Almost every aspect of the railway ay nagre-rely sa mechanical engineering, from track signals and trains to ticket barriers and tunnels. And even sa pag-elaborate ng control systems, a responsibility ng mechanical engineer as the mechanical engineer design and deliver embedded train control systems. Command, control, and railway signaling. Railway signaling is a system used to direct railway traffic and keep trains clear of each other at all times. Trains move on fixed rails, making them uniquely susceptible to collision. Basically, ang railway signaling is a mechanism kung saan si station master or yung controller ay kino-convey niya yung information or data kay driver or the loco pilot on when to stop, go with the caution, or proceed. There are two types of signaling system in railway, and these are time interval method and space interval method. Time interval method, where trains are spaced over a length of a track in such a way that if the first train stops, the following train driver should be able to stop the train in sufficient distance without colliding with the first one. While in space interval method, in this method of control over movement, the length of the track is divided into sections and called blocks. The entry of a train into the block is controlled in such a way that only when it is free, a train can be allowed to enter it. This means that between two consecutive trains ay mayroong definite space interval. The space interval method is further divided into two types. These are the visual and audible. Under audible, we have detonators, voice, whistle. And in visual, we have movable plug, fixed signal, and flare signal. In fixed signal, we have two aspect and multi-aspect. So, sa two aspect, we have semaphore and color light signaling. Same with multi-aspect, semaphore and color light signaling. Semaphore signaling. Signals which are rectangular or fish-tailed, arm fixed to a vertical post. The arm is rotated in different angles to convey information to the loco pilot. So these are stop dead aspect and then proceed aspect. Color light signals. Color light signals are used to convey information to the loco pilot. If it is color red aspect means stop dead. If it is yellow, it means caution, means proceed and be prepared to stop at the next signal. If it is green, it means proceed. And we also have the double aspect na ang ibig sabihin naman ay attention, proceed, and be prepared to pass the next stop signal at restriction speed. SCADA, SCADA, or Supervising, Control, and Data Acquisition, is an industrial control system designed to monitor factory and plant operations either on-site or from a remote location. SCADA, it is made up of both hardware devices and SCADA software that allow user to control and monitor operations. Basically, SCADA in railway it is a medium to convey data between a host and the equipment. Next is electrical engineering. Is the field of the study of generation, transmission, distribution, and the use of electrical energy. Electrical engineering in railways made its beginning with the responsibility of illumination and ventilation of railway stations, offices, and residential complexes and water supply. Railway electrification system supplies electric power to railway trains and trams without an onboard prime mover or local fuel supply. Electric railway use their electric locomotives, electric multiple units, or both. There are three main types of electric traction that exist in railway. These are follows. This electrification system. The choice of selecting this system encompasses many advantages such as space and weight considerations, rapid acceleration and braking of DC electric motors, less cost compared to AC systems, less energy consumption, and so on. The second one is the AC electrification system, or the this system has become very popular nowadays, and it is more often used in most of the traction systems due to several advantages such as weak availability and generation of AC that can be easily step up or step down. Easy controlling of AC motors, less number of substations requirement, and the presence of light overhead catenaries that transfer low currents at high voltages, and so on. Lastly is the composite system or the multi-system. Trains are used to provide continuous journeys along routes that are electrified using more than one system. These are the process of electrification system for DC electrification and AC electrification, as shown in the picture. Overhead catenary, or also known as overhead line, is an electrical cable that is used to transmit electrical energy to electric locomotives, trolleybuses, or trams. So, yung overhead line ay gumagamit ng alternating current while yung third rail is direct current. This method of providing electrical power to trains and locomotives using a semi-continuous rigid conductors which is placed either alongside or in between the running rails. Another subfield of railway engineering is civil engineering. A railway civil engineer specializes in the design, construction, and operation of all types of railway systems, which may include mainline, metro, light rail, or high-speed rail. So what is the role of civil engineers in the construction of railway tracks? So, the following is the stages construction of railway tracks. First is planning. The geometric design of railway, gradients, curves, tunnels, bridges, etc. Responsibility ni civil engineer na masiguro yung smooth and safe travel without excessively sharp turns or excessively steep grades, and also yung signaling and switching ng mga trains ay pinaplano din ni civil engineer sa stage na ito. Next stage is the design. Dito naman sa design stage, kinakailangan ng specialized civil engineers such as a structural and geotechnical engineer to design railway tracks, bridges, tunnels, soil improvement, and thickness of ballast bed. At kung ano pa man ang kailangan. Last stage is the construction. Dito, magsisimula yung construction, planning, scheduling, management of the project like men, workers, machinery, and fans, ensuring safety on site, etc., in order to complete the project safely within budget and on schedule. Permanent way engineering. Railway track, also known as permanent way. It is the structure consisting of the rails, fasteners, railroad ties, and ballast, plus the underlying subgrade. Oh, so what is the purpose of permanent way or the railway track? To provide the permanent facility for safety and quick movement of normal commercial traffic between the starting and destination stations. Next is light rail system, or mas kilala natin na LRT, light rail transit, is a form of passenger urban rail transit characterized by a combination of tram and metro features. But why there is a LRT? Light rail is in use to provide modern, high-order, rapid transit in world-class cities around the globe. Light rail can carry more passengers than streetcars or buses, and light rail vehicles can be joined together to meet growing demand. Another reason is they can operate on the surface and dedicated lanes, in tunnels or on elevated guideways fully separated from traffic, providing convenient comfort, speed, and reliability. Light rail are also electrically powered with no emissions, so not only will they help move people through the city, they are also environmentally friendly.
Hello everyone, I'm Jezabel Vinluan and I'm going to report the continuation of the subfields of railway engineering. So next is railway system integration, kung saan ito yung naninigurado na lahat maayos, lahat walang sira o walang problema. It ensures the rail systems, trains, and infrastructure combined with operations and maintenance inputs delivers a resilient operational railway engineering meeting customer requirements. Next is train control systems, are the hardware and software equipment that monitor train locations and movements in order to ensure safety. So ito nga yung mga equipments na nag-monitor sa lokasyon at galaw ng mga trains para makita nila kung maayos ba ito. At essential din siya para sa smooth traffic at pag may mga hazardous situation, ito yung mga nagpre-prevent sa mga train collisions. Nakapaloob sa train control systems ay ang cab signaling. Cab signaling is a railway safety system that communicates track status and condition information to the cab, crew compartment, or driver's compartment of a locomotive, rail car, or multiple unit. And two types of cab signaling is intermittent and continuous. So, para sa mas maayos na daloy ng railway, kailangan natin ng mga signaling katulad ng cab signaling para mas magkaintindihan yung mga cab, crew, or mga drivers. Next is rail vehicle engineering. You will be able to classify rail vehicles and to know their fundamental differences to road vehicles. So dito nga natin na pag-aaralan, nalalaman at na-classify kung ano ba ang pinagkaiba ng rail and road vehicles. Kung ano ba yung mga gamit nila, yung mga equipments na kailangan nila, lahat ng mga pinagkaiba nila. Next is rolling resistance, or sometimes called rolling friction or rolling drag. Is the force resisting the motion when a body, or pwede rin siyang ball, tire, or wheel, rolls on a surface. It is mainly caused by non-elastic effects. That is, not all the energy needed for the formation or movement of the wheel, roadbed, etc. is recovered when the pressure is removed. So nakapaloob sa rolling resistance ay ang curve resistance. Is a part of train resistance, namely the additional rolling resistance a train must overcome when traveling on a curved section of track. So from the word itself, curve, so ito yung mga resistance na kailangan sa mga pakurbang daan or minsan sa mga sinasabi nating banking. Next is wheel-rail interface. Is the area of contact between wheels and rails of railways. The interaction between wheel and rail is a specialized subject covering the design and management of the high stresses in the small contact area between a steel wheel and a steel rail. So ito nga yung sa mga gulong at ito rin yung major source kung bakit maingay yung mga train which disturbs both people in the surrounding and passengers. Nakapaloob sa wheel rail interface ay ang hunting oscillation. Is a self-oscillation usually unwanted about equilibrium. The expression came into use in the 19th century and describes how a system hunts for equilibrium. The expression is used to describe phenomena in such diverse fields as electronic, aviation, biology, and railway engineering. 6 types of railway system engineering is railway signaling, fare collection, CCTV, public address, intrusion detection, and access control. So first is railway signaling. It's a system used to direct railway traffic and keep trains clear of each other at all times. Trains move on fixed rails, making them uniquely susceptible to collision. This susceptibility is exacerbated by the enormous weight and momentum of a train, which makes it difficult to quickly stop when encountering an obstacle. So, itong railway signaling nga is para mas maging maayos yung daloy ng mga trains para maiwasan ang pagkakaroon ng collision. At exacerbated means making a problem worse. So, what makes the problem on trains worse is yung mga mabibigat na dala ng train. So, next is fare collection. Is the fee paid by a passenger for use of a public transport system. In the case of air transport, the term airfare is often used. Fare structures the system set up to determine how much is to be paid by various passengers using a transit vehicle at any given time. So aware naman tayong lahat na kapag sumasakay tayo sa mga sasakyan, kailangan nating magbayad. At yung bayad natin is nakadepende sa sasakyan natin at sa kung saan tayo pupunta. In the case of air transport, sabi dito, the term airfare is often used. Next is CCTV. Closed circuit television or CCTV, also known as video surveillance, is the use of video cameras to transmit a signal to a specific place on a limited set of monitors. So alam naman nating lahat kung ano at para saan ang CCTV. Nakikita natin siya sa mga malls, sa mga bahay, sa mga tindahan, at sa mga daan para mas maging safe yung place na yun. Next is public address. Public address system or PA system is an electronic system comprising microphones, amplifiers, loudspeakers, and related equipment. So ito yung mga equipment na nagpapa-aware sa mga tao or nagsisignal sa mga tao kapag may announcement or kapag may mga parating ng sasakyan, ganun. Next is intrusion detection. Also, intrusion protection system or IPS. Is a device or software application that monitors a network or systems for malicious activity or policy violations. An intrusion activity or violation is typically reported either to administrator or collected centrally using a Security Information and Event Management or SIEM system. So ito nga isang device or pwede yung software application na nag-monitor kapag may mga malicious activity na or violations at nare-report ito sa administrator or pwede din sa SIEM. And the last is access control. Access control or AC is the selective restriction of access to a place or other resource, while access management describes the process. The act of processing may mean consuming, entering, or using. Permission to access a resource is called authorization. Siyempre, para mas maging safe ang isang bagay, kailangan magkaroon ng access control or restriction para hindi basta-basta nagagamit or napapasok ng ibang tao. And the last subfield of railway engineering is system integration. System integration is defined in engineering as the process of bringing together the component subsystems into one system and ensuring that subsystems function together as a system. And in information technology as the process of linking together different computing systems and software applications physically or functionally, or to act as a coordinated whole.
Good day everyone, I am Engineer Villaraso and today I will discuss about the railway engineering, specifically its components. So first, let me give you a brief description of our railway engineering. Our railway engineering builds a better, faster, and more efficient rail systems. Sa madaling salita, it is all about rails. Railway engineering is considered an interdisciplinary engineering field. So ano nga ba yung ibig sabihin ng isang interdisciplinary field? Ibig sabihin lang yan, nire-require ng field na to yung knowledge and skills for a specific purpose, which is special skills in terms of railways. Nare-require yung expertise ng isang engineer sa field ng mga railways in order to make the railway engineering work. Paano nga naman makakagawa ng better and faster rail systems kung yung person in charge does not have the right knowledge to operate it? So again, yung mga railways daw na yan are incredibly complex and expensive systems, which is designed para magkaroon ng efficient passage ng trains to transport people and equipments. Sa unang tingin pa lang, it looks like it needs a lot of attentions and skills. So in that case, we can easily conclude na medyo komplikado nga talaga yung system ng railways, which will cost a lot of effort and money. So let us talk about its components. Meron daw 4 important components yung railways, namely the rails, sleepers, ballast, and subgrades. So ito yung isang example ng isang railway. So yung systematic rails na yan ay nakakabit sa isang specific number ng sleepers, which is yung pinagre-restan naman ng mga sleepers ay yung ballast and supported naman sa ilalim ng subgrades or yung mga natural soils. Ipinagkakabit-kabit ng mga welders yung mga components na to by using a fish plate. Yung fish plate naman na to, yung mga metal bar that is bolted to the ends of 2 rails to join them together in a track. Makikita rin dyan na nagko-consist yung track ng 2 parallel rails at a certain distance, wherein yung distance ng isang rail from another rail ay nakadepende sa laki ng gauge ng isang track. So first, let us talk about rails. A rail is horizontally extending steel bar between supports that serve as a track for trains, automobiles, and other vehicles. Sa railway system, yung mga rails ay considered as the first main element ng isang railway. Kasi ito yung bumbuhat ng wheel load ng mga tren, providing them a smooth way and transfer the load safely to sleepers. In addition, meron daw 3 types of rails, which is yung double-headed rails, bull-headed rails, and last is the flat-headed rails. The next component is sleepers. Sleepers are concrete beds in the railway tracks. So, ito naman daw ay considered as the second main element ng railway. So, unlike rails, yung sleepers na to ay fixed vertically to each other. Yung main purpose niya is to hold rails and mas mapatibay pa yung position nito na kaya mag-resist ng strong capacity ng weights. So, yung loads na nare-receive niya from the rails ay dinidistribute naman niya sa subgrades and dun sa ballast. Commonly, yung sleepers consist of concrete, timbers, steel, cast iron, RRC, and press-stressed concrete.
Ballast. Track ballast formed from the track bed upon which railroad ties or sleepers are laid. It is packed between, below, and around ties. It is used to bear the load from the railroad ties to facilitate drainage of water and also to keep down vegetation that might interfere with the track structure. So yung ballast daw ay piniplace siya below or around the sleepers para ma-bear niya yung load from the railroad. Tapos ina-avoid din dyan na magkaroon ng vegetation around sa tracks. So ballast are stone aggregates and gravels. These places below and around the sleepers. The main work of the ballast is to hold sleepers, rails, and provides them a strong grip. Stone ballast widely used in railway tracks in modern railways. So ito yung picture ng ballast. Kung makikita nyo, nasa paligid nga siya ng tracks. So uses of aggregates in railway ballast. A fully loaded train weighs in thousands of tons. To avoid damage to rails, ground, and other nearby structures, a very tough aggregate is needed not only to support this high weight but also to distribute and transfer it properly to the ground. So iba yung ginagamit na aggregate dito. So kailangan To avoid damage from the rails, kailangan very tough yung aggregate para din ma-burn niya yung load ng 1,000 pounds na train. So, railway ballast generally consists of tough igneous rock crushed, such as granite, with a large diameter varying between 30 mm to 50 mm. Particles finer than this diameter in higher proportion will result in drainage properties, while a higher proportion of larger particles result in the load on the ties being distributed improperly. So, dapat ang aggregate na ginagamit dito ay between 30 mm to 50 mm lang para ma-distribute properly yung load dun sa track. So, angular stones are used as ballast due to its physical properties that can they interlock with each other. Therefore, they are used to resist any movement of the rails and ties. Other use includes fills, backfills, and drainage and filtration applications. Formation of subgrade. There are natural soils on the bottom of a track. These are the foundation of tracks. It holds rails, sleepers, ballast, and the entire track together. It supports the railway track from the bottom layer. The role of the subgrade in railways is similar to that of a building foundation. So, kung yung building foundation ay merong soil, kung saan tinatay foundation, yung sa may track, meron siyang natural subgrade. Doon mismo nilalagay yung track. The effects of subsoil that cannot carry much load are devastating. Back in the 19th century, it was recognized that the proper drainage of water and the adequate dimensioning of the load-bearing capacity were key factors in the success of the railway system. So, kailangan, ang pagtatayuan mo na subsoil o yung subgrade ay kayang i-bear yung load at maganda drainage niya para dun itayo yung nang maayos yung railroad doon. Next, problems in the subgrade are often only discovered at the late stage. If muddy places appear on the surface, the effects on the complete system are normally so far advanced that it is necessary to replace all components, even though formation rehabilitation is significantly more expensive than conventional track renewal. It shows its positive effect when the complete life cycle cost of track is considered. Poor subgrade increases the maintenance and reduces the useful life of the railway track. So, in choosing the subgrade, kailangan talagang pag-aralan at pagplanuhang mabuti kung saan ito itatayo kasi poor subgrade increases the maintenance. So, sabi dito, even though formation rehabilitation is significantly more expensive than conventional track renewal, it shows positive effect. So, next, yan yung itsura ng subgrade. Makikita nyo yung steeper, pagkatapos yung ballast, sub-ballast, subgrade nyo. Kita nyo yung subgrade, yun yung original na lupang pinagtayuan ng truck. Okay.
Railway stations. A railway station is that place on a railway line where traffic is booked and dealt with, and where trains are given the authority to proceed forward. Sometimes, only one of these functions is carried out at a station, and accordingly, it is classified as a flag station or a block station. In the case of a flag station, there are arrangements for dealing with traffic, but none for controlling the movement of the trains. In the case of a block station, a train cannot proceed further without obtaining permission from the next station, and the traffic may or may not be dealt with. Purpose of a railway station. A railway station is provided for one or more of the following purposes. First, to entrain or detrain passengers. Next is to load or unload goods or parcels. Third one is to control the movement of the trains. Fourth, to enable trains to cross each other in the case of a single line section. Fifth, to enable faster trains to overtake slower ones. Sixth, to enable locomotives to refuel whether it be diesel, water, or coal. Seventh, to attach or detach coaches or wagons to trains. 8. To collect food and water for passengers. Ninth, to provide facilities for change of engines and crew or staff. The 10th one is to enable sorting out of wagons and bogies to form new trains. And lastly, to provide facilities and give shelter to passengers in the case of emergencies such as floods and accidents which disrupt traffic. Selection of site for a railway station. The following factors are considered when selecting a site for a railway station. Adequate land. There should be adequate land available for the station building, not only for the proposed line, but also for any future expansion. The proposed area should also be without any religious buildings. Second factor, level area with good drainage. The proposed site should preferably be on a fairly level ground with good drainage arrangements. It should be possible to provide the maximum permissible gradient in the yard. In India, the maximum permissible gradient adopted is 1 in 400, but a gradient of 1 in 1000 is desirable. The third factor, alignment. The station site should be preferably have a straight alignment so that the various signals are clearly visible. The proximity of the station site to a curve presents a number of operational problems. Fourth factor, easy accessibility. The station site should be easily accessible. The site should be near villages and towns. Nearby villages should be connected to the station by means of approach roads for the convenience of passengers. Last factor, water supply arrangement. When selecting the site, it should be verified that adequate water supply is available for passengers and operational needs. Classifications of railway stations. Railway stations can be broadly sorted into various classes on the basis of two main considerations. First is operational considerations. As per the general and subsidiary rules of Indian Railways, stations are classified as black stations and non-black stations. Black stations are further classified as A-class, B-class, and C-class stations. Non-black stations are classified as D-class or flag stations. Second, functional considerations. Stations are classified based on the functions they are required to perform. Under this category, stations are classified as halt stations, flag stations, crossing stations or wayside stations, junction stations, and terminal stations. Black stations. A black station is a station at which the driver has to obtain an authority to proceed in order to enter the next block section. In a railway system that is inclusive of block stations, the entire railway line is divided into convenient block sections of 5 to 10 km, and a block station is provided at the end of each block. This system ensures that a suitable space interval is provided between running trains so that there are no collisions and accidents. There are three types of block stations. The first, block stations, A-class stations. A-class stations are normally provided on a double line sections. At such stations, a line clear signal cannot be granted at the rear of a station unless the line on which a train is to be received is clear and the facing points set and locked. No shunting can be done after line clear has been granted. A-class stations are suitable for sections where traffic passes rapidly. It is essential for the driver of the train to have an advanced knowledge of the layout of the block station. B-class station. This is the most common type of station and is provided on single line as well as double line sections. At a B-class station, the line has to be clear to an adequate distance beyond the outer signal before permission to approach can be given to a train. C-Class Station. The C-Class Station is only a block hut where no booking of passengers is done. It is basically provided to split a long block section so that the interval between successive trains is reduced. No train normally stops at these stations. Non-block stations or D-Class stations. D-Class or non-block stations are located between two block stations and do not form the boundary of any block section. No signals are provided at D-Class stations. Functional classification of stations. The layout of stations varies in size and importance according to the type of and volume of traffic handled and according to their location with respect to cities or industrial areas. Broadly speaking, the layouts required for passenger stations and their yards can be divided into the following categories for the purpose of study. Halt. A halt is simply a station where trains can stop on a railway line. Halt usually only a rail-level platform with a name board at either end. Sometimes a small waiting shed is also provided, which also serves as a booking office. There is no yard or station building or stop provided for such type of stations. Some selected trains are allotted a stoppage line of a minute or two at such stations to enable passengers to entrain or detrain. The booking of passengers is done by traveling ticket examiners or booking clerks. A notable example of the halt is a Gurkshewar Bridge halt, which is situated on the bank or river Ganga. Flag station. A flag station is more important as a stopover for trains than a halt and is provided with a station building and stop. On controlled sections, a flag station is equipped with either a Morse telegraph or control phone, which is connected to one of the stations on either side to facilitate easy communication. A flag station is usually provided with a small waiting hall and booking office, platforms and benches, and arrangements for drinking water. Sometimes a flag station is also provided with siding or for stabling wagons booked for that station. Wayside or crossing station. After a flag station comes with the wayside or crossing station. While a flag station has arrangements for dealing with traffic but none for controlling movement. The movement of the trains, a crossing station has arrangements for controlling the movement of trains on block sections. The idea of a crossing station was initially conceived for single-line sections to facilitate the crossing of trains going in opposite directions so that there may be a more rapid movement of trains. Junction stations. A junction station is the meeting point of three or more lines emerging from different directions. Normally, at junctions, trains arrive on branch lines and return to the same station from where they started or proceed to other stations from where they again return to their originating stations. Terminal station. The station at which a railway line or one of its branches terminate is known as a terminal station or terminal junction. The reception line terminates in a dead end and there is provision for the engine of an incoming train to turn around and move from the front to the rear of the train at such a station. In addition, a terminal station may need to be equipped with facilities for watering, cleaning, coaling, fueling, and stabling the engines, storing, inspecting, washing, and charging the carriages, and such other works. That's all. Thank you.